All right, so first, how many people have trained a deep learning or machine learning model before? Yeah, nice. All right, very good. How many people have gotten like 99% accuracy? Oh yeah, all right, nice. Go. Would you trust your model with your life? No? All right, I actually wouldn't either, because I need a whole team to help me with it. But this is an example of when you might need to trust your model with your life. So there are, emergency braking systems being informed by a bunch of data coming from all over the place, and your AI model might be preventing death of people in front of that car. So that's what we're going to talk about in this session. We're going to go through some examples and really just make sure that, go through some of the ways that you can be more confident in your AI models and some of the things that you really need to think about whenever you're, incorporating these into real systems. So I'm from the Mathworks. We make MATLAB and Simulink, in case you've heard of it. Most people are like, oh yeah, I used that way back in college. Cool, it's awesome. But anyway, the point of telling you that is that we see a lot of this right now. So many Simulink MATLAB users are, trying to incorporate AI into these kinds of systems. And there's just a lot to think about. It's been actually a little bit slow going. People, this has been a great hot field for the last couple of years, and it's just really slow to adopt in these areas just because of the number of people involved, the number of critical systems involved, and the field is still relatively new for many people involved in this. So again, that's what we're going to think about. We're going to talk through some of the techniques whenever we're building these models for these systems. One of the things, this is sort of our typical AI kind of workflow, right? We have data, we need to pre-process the data, train our models, test, I'm going to say that a lot in this session, and then deploy, right? So that's kind of your typical, what I think of is if you're going to get the airline data set or, your Netflix recommenders, this is kind of what you do, right? So whenever you're starting to think about reality, you also take another couple of steps, right? So you have, we want simulations for failure data. Some of these things are anomaly kind of detection, so we don't have a lot of cases where the car crashed or, the brakes failed. So we'll simulate all of that. And then, of course, we want to test our simulation to make sure it's, close to our real system. And then we're going to test a bunch throughout this whole process, right? But this is actually just one part of an entirely bigger process, right? So, your design, especially if you're going into a vehicle, you're going to have physical models, you're going to have your control algorithms, logic, signal processing, and those may or may not be before the AI model, so you have to kind of think through the system altogether. And then, we want to generally put these onto a device, right? So some kind of, GPU or FPGA, something like that. So there's a lot to think about there too, and we'll talk through that as well. And then, of course, you want to integrate with the entire system, and all of this is all about testing, documentation, and in the end, you also have some certification. So if you're going to, put this in a vehicle or, I guess often these are regulatory kind of industries. I've heard a couple of conversations earlier even in insurance and things like that. So there are certifications, there are very strict rules for what you can do. And so, again, just a lot to think about. So again, there are a lot of people involved in this. It's not just one person trying to, solve a Kaggle competition. Sorry. So a lot of people, right? So, I tend to be in more of a data scientist realm, but you have your mechanical engineers, you have all sorts of people. And even importantly, you also have a manager and lawyers. I talked about regulatory industries. So everybody needs to be on the same page. And these are people with very different backgrounds, very different skill sets, different cares, I guess, of obviously the lawyer is is not necessarily interested in the exact details of the model, but needs that documentation afterwards, right? So, okay, what do we do? How do we start? First, we'll talk about model explainability. This is probably a hot topic. We've heard a lot about this in other conferences, and you'll probably hear a lot about this in the next 2 days. we'll also, talk about kind of taking those models now, deploying to hardware. Again, kind of what are those things you need to think about, what sorts of tests you need to do. Testing. Maybe we should start drinking every time I say test or something, because I'm going to say it a lot in this session. Wait, it's a bit early for that, I guess. But it's really, really important, and it's something that people don't, I haven't heard a lot of talks just about testing, and maybe it's not as exciting as I think it is, but we'll talk a lot about that. And then finally, pulling it all together, getting everybody on the same page, all those people on the previous slide, and deploying and going to town. So model explainability, again, very, very important, and especially in this field. So I think of sort of human and computer trying to communicate with one another, right? So explainability, basically you just have a bunch of questions, right? So how does the model come to this decision? Why does it work like this? Why is it failing? What are the conditions that lead to failure? In fact, you can actually get some of this information. So recently I applied for a credit card and I didn't get it. Now, I'm from the US. I have a lot of student loans, okay? So don't judge. But I did not get the credit card, but I was able to actually ask why. And I did get a report back of the things that led, student loan debt being one of them, but the things that led to my denial. It wasn't a very fancy classification tree like I was expecting. I was really excited, and I thought I would see all kinds of really cool stuff in my credit classification, but it was a very good list. So again, that's where we're headed. We need to be able to document these things and express what's going on. And then from the computer, I think of just, what do you want from me? We want to be very, very clear about the requirements and about what we're expecting from the model itself. And so again, we've heard a lot about this probably, or we will in the next couple of days. There's a lot of buzz about this in the community. It's really, really important. We're, again, trying to get these to be into real systems. So this is just a sampling that I found of some stuff out there in the community. Often these are, generally visualization techniques, which we'll talk about as well. And then something that's really related to what we're talking about is DARPA is a defense agency in the United States, and they've really invested in this explainability. So I know, just basically took this, thank you DARPA, but it's really interesting to me is talking about the questions that you need to ask, the way that we need to work together, and then we basically just have this explanation interface that we stick in here. I mean, of course, that's we'll talk more about that, but that's kind of the idea. Is instead of just going through, we want to actually have some kind of interface to get more value or more out of that model. So I think of it as, again, explainability. Well, who are we explaining it to? So it has to be explainable at least to some level to everybody. And again, maybe the lawyer doesn't need to know every last detail about the classification tree, but at some level. It's really important. And also the community, the rest of the people, the end users. And then interpretability as well. So we'll talk more about the models themselves, but generally you want to try to just make the most clear model with the most documentation if possible in order to interpret. So these are some of the techniques that you can use to improve it. A simpler model, the simplest is the best, I guess, even though it seems like we all want to just deep learn everything and add a bunch of layers and it's going to be awesome. But in reality, we really kind of want to understand what's going on and we want it to be simple. Visualizations, I'll spend a bit of time on this as well because that's a really valuable technique, and for humans especially. Documentation, of course, we're, again, this is kind of the thing that really will help with the regulatory industries, with lawyers, with getting everybody on the same page, just documenting everything that you're doing. And then we'll talk more too about simulations and testing. Of course, testing. So I like trees for simpler models because, although that doesn't look terribly simple, there is some sense to it. So if this is a case of braking hard or speeding, those kinds of things, and maybe it's not that interpretable, but if the sixth variable from the acceleration sensor is greater than blah blah blah, you can see what happened. But so again, it's maybe not something that you can sit back and be like, oh, totally, I get that. But at least you have a record of what happened and how each decision was made. You can also prune trees, which is my favorite. So, keep making it simpler and simpler. Like, you don't need all that. It might be fitting some noise. Just prune it up a little. This is overly simple, but for demonstration purposes. But again, that's kind of the idea is, maybe it's not the greatest, the easiest to interpret, but you have a path to do that. So just to be more clear, it starts at the top, goes down the branches, finds the leaf, and we went. But even simpler, in many of these cases, you could actually use physical models, you could use rule systems, those kinds of things. So, I think that's one of the things that people, okay, I'm trying to do AI, I'm trying to train this model, I'm trying to do all these things. I don't want to start with a 300-layer deep learning model. Think about it, So, don't always go for the big hammer. I might step back and think about what you learned in undergrad. So in terms of interpretability of models, this was from Gartner. I think had a similar kind of documentation about this. But so decision trees kind of fall somewhere in the middle. Again, I like them just because I think they're easy to see and understand. But even, logistic regression, naive Bayes, and again, rules and physical models, equations, those are also very, very valuable. And then as you, tend to increase in accuracy, or the deep learning models, as we've heard about a lot, I'm sure, tend to be very, very accurate and great. You need a lot of data and everything. But again, these are like much less interpretable. There are ways, we'll talk about ways to get there, but, much harder to understand for, well, most people, I guess. So in terms of visualizations, I think it's really important, especially, again, at Mathworks, we have a lot of hair in our microphone. We have a lot of people that are, we're a little hesitant to just take a deep learning model and train it and deploy. So helping out by, we have a little app that shows all the different layers. You can kind of click through and just get a little bit more confidence that it's not just some kind of abstract thing that you're sticking in there. And then, of course, this is a visualization example or an image example, so it's much easier to think through. We'll use that to start, but you can visualize activations, you can, any of the layer decisions, you can actually get information out of all of that. And then finally, it's really important to look at the results. So, not to de-emphasize that as well, just kind of going back, iterating all the time, trying to understand, why these things were classified the way they were. So, there are also techniques, just like mathematical techniques like GradCam and occlusion sensitivity, where you can actually kind of see a map of what, especially with images, a map of what is making that thing classified the way it is. So this guy, the puppy dogness of his face is in the ear area. So this can be helpful. Another dog, I don't know, I feel like you have to have dogs and cats when you're talking about AI, right? So this guy or gal, was classified as a miniature poodle, but possibly a toy. It's a gamble. If he didn't have a leash, I'd probably go either way, or perhaps a terrier. So you can use occlusion sensitivity to try to understand, why these things are being classified the way they were. Looking at it, it's still a toss-up whether it's a toy or like an actual poodle. But again, you can kind of see now the terrierness is sort of in the beard of the dog. So again, kind of helpful, especially if you have similar kind of images or things that you want to compare. So it's easy for images. Like we said, you can visualize activations, you can visualize all sorts of stuff. But you can do this for anything, really. So stepping back to our hard braking example that I had earlier, these are some of the predictors from our machine learning model, and you can just look at the importance and take a look at that kind of stuff too. So it's not just images that you can visualize, basically. Also signals. So we hear a lot about that. So we tend to look at the spectrograms, some of the spectral information to again kind of understand why certain things are being classified the way they were. This was just a voice detection example. So I talk a lot about documentation, and this, well, may or may not have anything to do with this example. But again, the idea, you need to remember to document, especially for machine learning AI, where's the data coming from? How did you split up the training test and validation sets? And this is also something, I decided not to go too far into it. I'm very passionate about it, but there's a lot of bias in AI, right? You may hear about ethics and stuff this week. And so documentation, I think, is a good way to kind of check yourself. Where is this data coming from? How many of this or that do we have? Just getting everything out there is a really good way to kind of identify those things. And again, across the board, we need everybody to understand what's going on. So when you're handing something off, you're going to need to explain it. So do that. So in terms of simulation, I think it seems many of us might not be as familiar with physical model simulations, at least from conversations I've had this morning. Maybe that's an unfair judgment in just an hour. But this is an example from RAND where you need 11 billion miles of testing to just demonstrate that it's 20% better than a human driver. So, this is just an example of the magnitude of what has to go into these things. And this is even without the AI involved. So it's really, really important. And you can, again, we'll go through some of this, but you can test for model confidence. So, again, we don't have a lot of bad emergencies, I guess. Most people are driving just fine. So we can simulate those crashes and, close calls. And then again, whenever you're trying to go through the whole system, we're going to want to, simulate as much real data as possible. So, I mentioned these are anomaly detection kinds of examples. And so there are techniques, of course, you could use, boosting algorithms, other kinds of techniques, resampling, data sampling stuff that you may have heard about before. But also, you could just generate data when you're crashing. So that's a really good way to do that and kind of enrich your model, enrich your data set. All right, this is a video. Fingers crossed. Okay. This is just an example of, it's a block diagram that shows some of the components. This is actually a lane detection. The braking one looks kind of boring. But so it is not moving anymore. Okay, now it's moving. Basically, yeah. Okay, good. I'm having a moment where I'm not confident about my video working. But so this is just an example. It's lane detection, again, not the braking part, but it's showing, capturing video from the car, using that to detect the lanes, and so this is kind of the path that we would go through for braking as well. But just to give you an idea what this looks like. Okay, we made it through that slide. Yes. All right, so now we'll start talking more about what we need to think about for the next step, really moving to reality, right? So again, we kind of maybe don't think as much about this whenever we're first starting out in our research, but these are going to be used somewhere, right? And what happens? We have a lot of different kinds of hardware, GPUs, FPGAs, those kinds of things, and then also cloud. You could have models running all over the place, or both in the same, system. So one of the things that is really helpful is to think ahead, right? So before, at least for me, I just want to jump right in and start messing around with data, trying different models. It's really fun. But you have to stop and plan and think. So we need to get requirements, not only how the data is coming in, typical kind of requirements of what we're trying to do, but we also need to get requirements from, how much data is going to be coming into the system, how much, what's the latency that we need, those kinds of things you really need to think about before you even start training your model. All right. So again, we kind of are sensitive to this at Mathworks because so many people they're going to do something with their model, right? So we try to provide apps to help package everything up. There are a lot of dependencies that come into these things. So again, just kind of the best you can do to help package that up and enable the handoff to the next person, basically. That's kind of the key. So in this case, MATLAB Coder will recode the stuff. So anyways, the idea is to package up your model and then just hand it off in whatever form it needs to be in the next phase. So testing is so important. I've thought many times about just doing a whole talk on testing, but no one would come to it. So here we are. But I think rigorous testing in this case is just even an understatement. You need to test absolutely everything so much. There are edge cases, especially in these, you really, really need to understand the edge cases. So that's why it's taken so long for these things to come out, because really need to understand every possibility in the system. So you also, probably have heard of similar kind of useful techniques in AI. We saw confusion matrices and doing those kinds of things. But you also, again, need to just test in operation, right? So this is an example. If you're testing on cloud, we try to spin up a little baby server so you can actually, use it properly. And let me tell you, that is where it starts to fail. This is where it's like, oh, this is going to look so great, and then I start testing in reality. And I didn't think about the way the JSON was coming in, or I didn't think about the way the timing and things like that. So it's really helpful to try to get out of the system. Now this is a very early version of my delightful hand drawings, but I like it because I was like, oh, test. So I thought it was maybe boring for the early slides, but also just shows every single phase you need to test, and that could be writing. Actually, I think, yeah. So testing the simulation, testing the machine learning model, and testing before deployment, right? I keep seeing people taking pictures, so I stopped. I didn't want to go to the next slide. I was like, oh, I can get a nice pic for Insta or whatever. So as you see, there are tests everywhere, right? So we really want to make everybody able to write the tests. Engineers, even the plant manager or the lawyer, if they really wanted to. This, at Mathworks, it's very, very important to us. We have, I don't know how many thousands of quality engineers employed that just constantly are testing these things, especially when we're trying to tell people that they can use it in production, right? So we've actually, a couple of years ago, exposed our unit testing framework so anybody could use it for their own tests. And importantly, you can write scripts. I don't know that there's other, it's just awesome. I have conversations with scientists, and they're like, "Oh, what? I don't test." I'm like, "Do you use your model?" And they're like, "Well, sure." Like, there you go. That's a test. And they think of it testing as building up this proper thing and having all this complications with it. Just drag and drop your code that you just tried and put it in a test suite. No big deal. So you could have different languages. All sorts of stuff. Just really, really helpful to kind of have everybody on the same page. Okay, it's moving. So this is an example of the braking system testing in production. So it's just generating scenarios over and over again, just driving and braking. Any failed tests will show up. And importantly, again, you need to document all of these things. So you're going to run bazillions of tests, but you also want to really examine the results and understand what happened with those. So here it's just showing generating a report that you could send to anyone, even the lawyer, I suppose. Just again, kind of showing why, when the tests passed and failed, why, and then you can add your own kind of documentation there too. So again, very, very important. Can't stress it enough. Sadly, it was only 4 slides in the end, but test it. All right, so now we're pulling everything together, right? So thinking back, we've got all these components, all this stuff going on, all these people involved, but really, you want to keep it together the whole time. You don't want to have everybody, independently kind of working on these things, and then just say, oh, okay, here, let's just integrate now. No, we need to be communicating and working together the entire time. This is an example of one of the braking system projects in MATLAB. There's a lot of code, a lot of dependencies. But again, everybody can kind of see this transparently. You can see when somebody makes changes. Definitely use of GitHub, source control is very, very helpful. I also, many people aren't as familiar with GitHub or sort of the developer kind of workflows. So we also kind of provide apps for that to just ease everybody into it if they're not familiar with command line stuff. But again, it's just really important to just get everybody on that same page. So I made it sound really hard and impossible and awful, but it actually can be done. So we're really seeing more success of incorporating these models. Hopefully, everyone here will go out and be very successful in incorporating their models into real life. There are links on here if you want to check them out. I think they're sharing the slides afterwards, so you can read all about it. And hopefully throughout this talk we've gotten some tips, tricks, so hopefully you have heard the message of testing, so that you're able to think about putting models into reality. I don't know if you'll trust it with your life necessarily. I still don't trust mine with my life, but I'm getting closer. So thank you very much. I think we have some time for questions, and really appreciate your attention. Thanks.